The ear is made up of three parts. It is made of the external ear, the middle ear, and the inner ear. Sound is heard as wave compressions. The waves are first brought in through the pinna. The pinna is a huge funnel that is used to bring in the waves and push it through the ear canal. Then, something called a tympanic membrane, also more commonly known as the eardrum, takes the vibrations that has been sent through and passes them to the middle ear. The middle ear consists of three tiny bones that are known as ossisoles. They consist of the malleus, which is also known as the hammer, the incus, also known as the anvil, and stapes, which is also known as the stirrup. These three bones take the leftover vibrations, which have been processed through the tympanic membrane, and they pass them on to the cochlea. The cochlea, as you can see, is that snail-looking piece in the inner ear. The cochlea is made up of liquid. It's like a liquid-filled tube inside the inner ear. The cochlea has a lot of cilia, which is just a bunch of little hairs all over it, but mostly on its tip. The cilia play an important role in the sense that when the hair cells are triggered, nerve impulses send messages first to the auditory nerve and then to the auditory cortex in the brain. That is how we send information out. Also, after you get the liquid is moving in the cochlea because of what the three osseoles have interpreted. So after you have the liquid inside of it, the vibrations cause the oval window, which is in the front of the cochlea, to vibrate, and that moves the fluid in the cochlea. That in itself gives us sound. The whole process of that is known as an acoustic transduction, which is the changing of the sound from various forms of wave to liquid, and it ends up becoming energy, which is what we hear. Now, after all that, there are two theories about hearing. There is the frequency theory of hearing, which says that no matter what pitch of sound, of wave of sound, it is always processed to the auditory nerve, and each nerve sends out the process. So it really doesn't matter. And the problems with this is that high-pitched sounds cannot fire fast enough, so the neurons cannot fire them fast enough, so that's a problem. And the other theory is the place theory of hearing, which proposes that the ear has different areas of the cochlea which respond to the different frequency sounds. So that theory is a lot more acceptable in a way.